So anyway, Kristen Baranowski, homegrown, right in town. And you know, I don't know Kristen that well. It's just I do know that she was behind our boys in school. I know that she was in band because when we went out to Washington, D.C. to march, she was on that bus with John Brody and myself and our boys. So I know that she sold a lot of rocks for her dad, who's here. So anyway, I know that you have a degree in biology and you went to La Crosse. And then you had this great opportunity to study. So I don't know all the detail. I think I'm just going to let you explain it, and I want everybody to give her a good round of applause.
Well, you think I'm okay to talk?
I think so.
Okay.
Why don't we see if you're okay?
Right here.
Oh, here?
All right. Hi, everyone. Welcome. My name is Kristen. I grew up in Green Lake here. I graduated in 2016 from Green Lake High School. I then went to UW-La Crosse to get a bachelor's in biology, and I graduated in 2020 with that. However, the world was a little bit weird in 2020, so I wasn't sure what to do. So I talked to my advisor, my ornithology instructor, and I said, hey, do you mind if I become your first master's student? I'd love to keep working on this owl project and see what else is possible. So I just graduated with my master's, officially a December graduate, so that's exciting. Thank you. And today we're going to be talking about my thesis, which was called Foraging, Ecology, and Space Use of Breeding Flammulated Owls in northern Utah. So I took out a little bit of the boring statistics and I threw in more owl photos for you all. Because who doesn't love owls? Who doesn't love owls? Comes naturally. All right, so an overview of my presentation. We're going to start with some background knowledge. I'm going to introduce the owls to you all. We're going to touch a little bit on why I was studying these owls in the first place, and then I'm going to break down some of the methods that I did over the course of my project and wrap up with my findings and my conclusion. All right, so this is the flammulated owl. It is best known for its dark eyes and the flammulated stripe down the backside. It is a small owl, so it's about 18 centimeters tall, and depending on if it's male or female, it is between 45 and 60 grams. So that is about this big, right? It fits right in your hand. It is a strange owl because it's insectivorous. So it eats insects, it doesn't prefer mice, does not prefer rodents, mostly moths and butterflies. And we find this in mid-elevation mountain range forests. All right, so I threw a map on here for you all. And as you can see, all out west. So if you haven't seen it in Wisconsin, don't be alarmed. They're not supposed to be here. Although with those flamingos that have been around, who knows, right? But during this time of the year, they're in southern Mexico. But otherwise, when I study them during the summer, they're right here in Utah. But they go all the way as far as Canada, which is kind of crazy for an owl so small to travel all the way from southern Mexico all the way to Canada, I think. But they are cavity nesters, so they prefer woodpecker holes or boxes. They are monogamous, so they'll keep the same mate for the whole breeding season, but they don't mate for life per se. And then the average clutch size is 1 to 3 young. So here's a photo of 2 young right in the middle, a little family. All right, so over the breeding season, starting in May, the female will pick a territory. She'll establish a mate, and they'll pick a site for their nest. So again, a cavity or one of our nest boxes. So after the female establishes, she'll lay eggs, and eventually those eggs will hatch, and then she'll keep incubating the eggs or the young for 21 to 24 days. So she's in the box the whole time until they get to about this size, and then she'll start feeding at night with the male. All right, so the young will grow for 17 to 26 nights. So if I go back, this is about 5 days old, I would say, and then we get to about maybe 12 days, closer to 20, and then ready to fledge, so maybe 30 days old, 25 to 30. All right, so I think this specific owl left literally the next day after we had checked the box. We walked past it and nobody was home, so we were like, wow, like this is as old as they get when they leave. They got all their feathers, but still a lot of down to keep them warm. All right, so what do these owls prefer for their breeding range? They like the mid-elevation mountain ranges, as I mentioned. They like the mature trees with cavities, and then they prefer open pastures with thick understory that holds those insects there, right? So they have food in mind when they're picking these areas to live. All right, so some common tree species that I worked with, I did a lot of vegetation surveys. So we actually didn't see the ponderosa pine, but Colorado will see that. Other areas out west see that type of tree. We see the quaking aspen, which is pictured here, Douglas fir, and Gamble's oak, and 2 different species of maple. So when the owls forage, there's some literature out there from 1986 where they found out with radiotelemetry that they often forage on the edge of habitat. So you can see these little dots here on the edge of a different habitat, and they suspect the forest provides protection, shelter from predators, and then the open grassland has the abundant source of food, right? The moths prefer that herbaceous vegetation. The herbaceous vegetation prefers lots of sunlight. You got the best of both worlds if you're on the edge, okay? So we'll keep that in mind as we move forward. They have different foraging strategies when they go out to find food. The most common is they're a perch and weight predator, so they'll glean or pick an insect off a branch. They do different versions of this, so a hawk glean would be to fly in like a hawk, pick the insect off the branch. Hover glean is hovering in place and then pick the insect off the branch. And then we've got the hawk, where they'll just fly in like a hawk and out of midair grab a moth or a butterfly. All right, so they do have beaks, so they can only carry 1 food item at a time, and they are most actively looking for food that first hour after sunrise. So we'd go out around 9 o'clock and be catching them, seeing them most often from 9 until maybe 11, 11:30, and if we didn't catch them by 12, we would wrap up because they're not quite as, they hunker down a little bit, so they have just kind of like middle of the road activity throughout the night, and then before sunrise, they're active again. All right, and I pulled this image and this information from a primary source. They study owls in Colorado, so very similar to our work. All right, so that is my little introduction on flammulated owls, but don't worry, there are more pictures and videos coming. We're just going to talk a little bit about why we study these owls. All right, so mountain climate is very unique. It's very specific. We have specific temperature, we have specific precipitation or rainfall, and we have a very specific timing for our snow melt. All right, these are all very important things to the plants that live there, and then the insects that are supported by the plants. All right, and so this is an issue because of phenological mismatch, which just means the seasonal pattern of one species, if that doesn't align with another species, you get that mismatch that can cause issues. So for example, the flammulated owl, they need that peak insect period to be mid-June and mid-July when their young are growing. Because if your young don't get big, they're not ready for migration, they're less likely to survive onto the next season. So the parents are thinking, the more I feed my young, the bigger they get, the more likely they are to survive onto the next season and pass on those genes onto their offspring. All right, so with some climate change, we are predicting hot and dry climate. So that means more fires, that means more stressed plants, which could lead to an increase in disease and pests. Just like you, if these plants are run down, they're more likely to have, like we get viruses, same thing except for in terms of pests. All right, and how might this affect our owls? Well, they like those mature trees. If there are less mature trees because of fire, where do we nest? Do we start to build nests? I don't know. That's why we're studying the owls. They prefer the open areas, like I said, for foraging. With fire, you never know how different species will adapt to those open areas. All right. And then my last background information, I'm going to cover a little bit of optimal foraging theory, because that relates directly to my project with the owls. So optimal foraging theory has all to do about how these owls select which spot to go to find food. Okay, so the theory is used to predict how an organism will behave when foraging for food. So ideally, the energy that the food gives you will give you more energy than it took to catch that item. All right, so if they're chasing this moth and they chase it for a while, that better give them a lot of energy to be able to go on and reproduce and find more food, right? So any energy expended. So for other creatures, this might mean handling the prey or eating the prey. If you have to do more work to be able to eat, that better be worth it, right? So some species actually conserve energy in different ways because it's hard to keep finding food. So the ovenbird here just tends to nest closer to its food. That's a way, less travel time, right? More energy to breed or defend against predation. Owls forage at night. There are less predators at night. The only thing that will eat my flammulated owls is a bigger owl, right? But otherwise, if they live during the day, you've got so many other creatures to worry about. Sit and wait predators will multitask. So we got our osprey here. They might be finding mates at the same time that they're finding food. They might be managing their territories or avoiding predators. These are all things that you try to reduce the amount of energy you spend so you're successful. And then you go on to produce eggs and pass your genes along and have offspring and incubate that offspring. All right? So for optimal foraging, it all starts with a choice. We have patch 1 with many moths available, and we have patch 2 with only a few. So how do we decide which patch we want to go to? Well, if there's more food there, it's an easy decision, right? Same thing. Okay, now that I'm at this patch, how do I know which food item to pick? Should I go for this moth that's pretty small, or should I go for this moth that's a little larger, provide me more energy? Yeah, there you go. He's eating well tonight. What do you think? And this all is related. So we got our plants that come after the snowfall. Our plants then allow our insects to lay their offspring there. And then our owls come in and provide the top-down control of the ecosystem and eat all the insects so that the plants aren't too harmed by them, all right? It's all balancing out. Okay, so now to drive a little bit more into my research and how all this information applies. So I studied flammulated owls. I study where did the male flammulated owls go to find food, and what is it like there? What does the habitat look like? What do they seem to prefer when they're going to these places to find food? All right, so we're back at now. I'm going to dive into my methods. We're going to talk about what I did in the field. Oh, aren't they cute? I thought I said 1 to 3 young. Well, we had 1 nest with 4. That was kind of crazy this last time. So I study these owls out in Utah. We are just north of Salt Lake City here. And I have 4 different areas that I went to with boxes. I had my Manaway site up here. I had my Public Grove and my 3 Canyon, which are pretty close to one another. And then I had Snow Basin Ski Resort, which some of you might know that's where the 2003 Olympics were held, I believe. But it's an open campground where we have boxes. All right, and this is all part of the Wasatch Mountain Range in Utah. Okay, so at each of my study areas, we have boxes like this put on our trees. So this is my quaking aspen tree there. And what we do is we go through and check all these boxes throughout the season to see who's occupying them. We have about 200 boxes throughout all 4 of these study areas that we check, and approximately 5 to 10% of them get used throughout the season. Because some owls prefer these natural cavities that we aren't able to access as easily, right? And what makes Utah so unique is that we don't have the ponderosa pine, which is a species of tree, and that kind of makes Utah a little bit different than all the other areas these owls occupy. So that's why we're doing the habitat surveys. We got such a unique area in this, in Utah. So step one, we go to every single box and we stick a camera in there to see if anyone's home. All right, so here's a picture of somebody was home in one of those boxes. And then once we know that, we make note, okay, this is an occupied box, and we let that owl be, because we don't want to disturb the owl. The owl just got there. The owl is just settling down, just deciding this is a safe place to have eggs, to raise young. So what we do is we come back after a week. We let her be. Then after a week, we come back, and what we do is we sneak up on the box. We take a hat, like this, or like that, and we stick it in the hole of the nest box with this stick. All right, so you're tiptoeing through all this loud vegetation. You step on a leaf, and that owl is there looking at you, and you're like, sorry, I'll be going, I'll come back later. But then after you plug it, you can take your ladder, set up, and then the tops of these boxes just slide off, and we can then safely remove the female out of the box. Or in this picture, there are a few young coming out. Yeah, and then what we do is for my advisor's project, we check the weight of the female, we check the weight of the young, we take a lot of data. But sometimes we check boxes and there isn't an owl in there like we would expect.
Just pull it out. Maybe it's a red squirrel.
So we get red squirrels in some of our boxes, and they are not happy to see us, let me tell you that. We had to walk past this box the whole season because there was another box past it, and every time we're tiptoeing by, it was just a chirping like, what are you doing here? This is our territory, we hear you. And then at the end of the season, we go through and we do some maintenance on our boxes, just to see what we have to fix for next season. So while we were checking boxes, we found out a different animal that likes to occupy them.
Woo! It's a baby.
A flying squirrel. How exciting, right? And I just got lucky by having my phone out. My advisor's like, oh, I think there's a squirrel living in here. Yeah, there was. And sometimes we see owls, and they're not the owls we would expect to see. So you all might be familiar with this species. Any takers? Northern saw-whet owl. There we go. So we stumbled across a female northern saw-whet owl.
Now quickly going to measure her.
Sure.
So we got to band her.
The band is still in the scale case.
Oh, yeah. So you might notice that the claws on these are quite larger than my flammulated owls. That's because they eat rodents. They need those bigger claws, right? And then she had 2 young in her box. All right, so this one is more fresh, right? Not as cooked as, say, this one. But again, you can see those larger feet, all right? I don't know, not the cutest owl baby. Flams are cuter. And then we took a look in the box, and they're stashing little rodents in there for later, right? So mom's been hard at work. We got probably 4, 5, maybe 6 in there, and then an egg that didn't hatch. So, oh well. All right, so going back to checking nests. So for my instructor's data, we go to every nest once a week to check on how they're doing. So we do this during the day, since the females are a little more groggy, you know, they're sleeping. So then once we get the females and whoever else is in there, we take a look and we collect some data. Oh, I love this one. He was looking at me, or she was looking at me. Oh, there's the babies. All right, So first, when we collect, we go to the nest and we trap the female. The first thing we have to do is put a band on her.
She's now known forever as this number. I don't give my birds names. They have numbers, and that's fine. I'm getting too attached. Okay.
Yeah, so here you can see my field tech, the one that screamed from the flying squirrel. She's putting a band on this female. So you got to squeeze really tight so that the band closes all the way.
Yeah.
And then you rotate to make sure there's no feathers caught in there. Because if you get feathers in there, that's bad. And then you also have to watch for their their foot. So she's just checking to make sure that's okay. All right, and then we give it one more squeeze. And this time you line the clamp up perpendicular to make sure that it's solid. But first we band them to make sure we know who's who as we move on. Then we take some other measurements. We take how long the tail is. We take from the wing all the way to the longest feather, so from here, the ulna, all the way to the longest feather, just to see how big the owl is bone structure-wise. We also take their weight. So an owl could be bone structurally like have long wings, but it might be low on its nutrients. So then we can kind of figure that out by taking some of these other measurements. But we check the weight, and then we even check the weight of the young. So this is a pretty fresh young, maybe 1 to 3 days. Yeah, very short wings there, but you gotta measure it. And then we measure the beak. All right, we take 2 measurements on the beak from the top all the way to the base, and then we take from the middle. Yes?
So in an entire season, about how many times do you actually handle the bird?
I think during a season we probably check in about 7 times with each nest. We start checking them June, and then we usually finish last week of July. So as we get done, the female's no longer there. It's just the young. The female's in a tree nearby watching over, but it's just the young at the end of the season. But yeah, usually about 8 times. Sometimes more often, which like for my project, I'll add a little bit what we did, but at night sometimes we check them too. So yeah. Oh.
That's checking them, but how many times do you handle them?
Yes, once a week for about 7 weeks. And then sometimes we'll handle them twice a week the summer that I was out there because we were trapping at the nest anyways, so we already were disturbing them. We just took a quick measurement and then we didn't have to come back quite as often. But what I was saying about the beak, so we measure from the top all the way down and then the cere, the nostrils all the way down and get 2 measurements there. But here's some young. This one's pretty old, in the 20 days old, and then these are a little younger. So this age is really enjoyable. Oh, and he says, hey, if you're not gonna eat me, why don't you feed me? That's what that was. That was a begging call.
Feed me.
Feed me. But we get all kinds of different personalities with our owls.
He's dancing. He's sleepy. He's a dancer. And Sleepy the second.
So some put on the whole like, I'm already dead, don't touch me anymore. So 2 in that video. And then one's just there like, yeah, you could feed me. I don't care. And same with the parents. Some of them close their eyes and they don't want anything to do with you. Others are biting my finger, which hurts quite a bit. And then you get kind of the third where she's there, she's paying attention, but she's pretty quiet. Oh, and here you have another video. And you can see the egg tooth on there, right? That's what they use to crack the shell. That's how they get out.
So I want to see how they feed for young with the cameras. Just I'm excited about that.
And because we just cut the nail the other night too, that would be awesome.
Okay, the biggest one.
2 of them?
Yep.
All right, so here's another fun age, my favorite. Again, feed me.
The ladder solid's not going to go anywhere.
And then when we're done, we take them and we put them back in their box. So this is me putting back, I think, my first
one more
young.
step, that's totally fine. It's a bit unstable. Yeah, balance with that left hand. That's perfect, even with the bird in it. So now, just kind of get a feel for the setup. Lift the lid. See that little wooden foot that is underneath the lid?
Oh yeah.
All right, so that was day trapping. We do all the day work for my advisor's project. He studies the female owls and how they actually lose weight over the season, and then the young, they grow over the season. So they have this opposite relationship. The parents are working hard to feed the young, they're losing weight, and then the young, they're actually just sitting there and eating. I don't know how parents do it. But then for my project, I did the night trapping version. So we trapped at night to find the male flammulated owls because they are delivering prey at night. And then if we were there disturbing the box and we say caught the female, we then took all those measurements I just explained at night because you want to disturb the box as little as possible. You don't want to be there all the time because you could force the parents to abandon their young, and that's not what we're here for. We're just here to collect our data and to learn from it. So here you can see I'm banding a little young here, and then this is a good video. He's hooing. Very quiet, right? Right next to me. Oh, so cool. All right, so how do we even catch these birds at night? I mean, the male doesn't live in the box. He only delivers for a few seconds and then gets out. So so in order to catch him, we set up what is called a mist net. So we've got a pole here, and then nets with different shelves that run. And then we fasten them to the vegetation around the box. All right, so we got different lengths. 4-meter mist net works the best. Well, depending on how dense the vegetation is. If you just have 4 meters, it's pretty much right in front of the box. And so what we do is about 7 to 10 days after we know a female is living in one of our boxes, we went in to collect my data at night by putting this mist net above. And again, we did it 7 to 10 days after the female had already invested in the young. She's already laid eggs. There's a less likely chance she'll abandon. So we went in and with the proper permits, the bird will fly into the net and get tangled up and fall into a shelf. So they're not harmed in this way. It's just a way to get them all tangled and then they can't fly out of it. And we're sitting nearby. We're actually very quiet. We hear them fly into the net and start to roll around and get tangled. So we're pretty quick to come and check on them then. And if we don't hear, we check about every 5 minutes just to make sure that we're there when the bird hits the net. But sometimes it's night, we're in Utah. Of course there's other animals. Sometimes we catch things we don't intend to catch. And luckily my advisor worked with bats when he was working on his master's, so he's able to help with this and had his pre-rabies shot up to date, so that was interesting. And then, of course, those darn squirrels. So this video went on quite a bit, but I don't think he'd appreciate me sharing the rest of it, because after that squirrel started chewing his net up, he was not happy. Oh yeah, there's some other creatures we see at 1:30 in the morning at a campground.
Yeah.
So eventually, the Boy Scouts, I guess, camp about 1 weekend a month, and we were like, what is that light shining by one of our nests? We better check it out just to make sure our owls are okay. And we showed up and he's standing about right in front of our nest with this dinosaur costume on. We're like, huh, interesting. Okay, so when I catch the males to collect my data, I take some different measurements than my advisor. So I was checking the condition of the male. So that means I was checking his weight, how heavy are you, his wing cord, how big is your body in comparison, and then we did some fat level checking. So are you fed well? Are you eating a lot of food? Are you struggling to find food? And so we do this by holding the owl and gently blowing into the feathers So here we're checking the clavicular region. So if it is flush with the rest of your body, you're doing pretty well. If it's bulging, you're eating really well. And if it's a little bit stuck in, not so well. And then we also check what would be on us, the armpit, under the wing. Is there a layer of fat that runs there? Is there no fat? Bulging fat? And I all kind of use this table to rank. We use a number system. So every time we caught the male, I checked these 2 locations to see how fatty the bird is. So here you can see for the clavicular, not very fat. And then here's that bulging, which most of my birds are between 3 and 4, so they were all doing pretty well. So each bird was measured 3 times. I captured each of my birds 3 times. Once was the initial capture, so I put the GPS transmitter on at the initial capture. The second capture, I took that GPS unit off and put a new one on, so that was the second time. And then the third time, we're just capturing to take the condition measurements and then remove that GPS unit off. All right? And so here's a GPS unit. All right, it's pretty small. It has to be about, I think, less than 3% of the owl's weight, which is crazy because these owls are 1 to 2 pounds. So this is not a very heavy unit. So this GPS stays on them for 6 days. We do that on purpose, so every week we're visiting. We're not visiting too often, not enough. I have to capture the owl to get the data back. With technology, there are units that you can just get close to the owl and it will sync the data. Unfortunately, not for this size of unit. Bigger units like hawks can do that. So, yep, we're captured. Take the old GPS off, put a new one on for a second week. That's all I needed. I needed 2 bouts of data collection. And then at the end, I again captured my unit and then removed the GPS and let the owl be. So I think it's pretty cool. You can see his nice little whiskers he has here for night hunting. And you can see that nice flammulated stripe down the side. Very good question. It is attached like a backpack. So it goes around the wings, and then we use a little clamp in the front that we squeeze with the pliers. And we use some braided, I believe it's braided fishing line. So then we do a pencil test. So if a pencil can fit in between, that means there is enough space that the owl can gain weight and not be harmed. And then if it is tight on the pencil, it's not too loose that it will fall off and cause the owl harm. So there's a very fine line between making sure that this is on properly and not holding the owl for too long. We want to make sure that we do what we need to do, put them back in, and let the owls be, let them hunker down and continue to feed their young, right? So there's that GPS again. As I mentioned, the size of this GPS unit is very small. So that means there's not a lot of battery and there's not a lot of space. So my location points were taken every 15 minutes, only for the first 3 hours at night and only for the first 3 hours at dawn. All right, so not ideal for trying to figure out where these quick owls go, but best we can do at this point. Oh, and sometimes you need a wide open sky to get good satellites hitting. So here's my advisor. I made fun of him during my thesis defense, standing on his car to try to get good satellite coverage before we put the GPS units on the owl. All right, and then once we're done with our owls, we let them go when they're ready to go. So here's a video of me. You can see that GPS unit on the male there, and we just let them leave when they're ready. I'd say 5 minutes is probably the longest. But there he realized, oh, I can go. All right, so once I have that data, I have to go out and find where the owls were going. So that involved a lot of hiking. We assume that these are foraging sites, but obviously there is some doubt there because it's not running continuously. It's only taking a point every 15 minutes. So then once I got there, I did some habitat evaluation. So here you can kind of summarize. If the owl point was here, I did a herbaceous richness well, I'll cover each one of these in more depth in the next few slides, but right next to it, I want to know which herbaceous plants were there. I was interested in woody plants. I wanted to know some other canopy cover, how dense the canopy was, so I took 3 canopy measurements there. And then we also did tree density and took some insect traps. So starting with the quadrat, it's just a 1 meter by 1 meter quadrat. You throw it into the vegetation and you ID all the species that are there, and you take a relative percent cover just to see, okay, what percent of each species. Then I did my canopy cover, so obviously this would be a very open canopy, very dense canopy, and it has this nice little mirror in it that you're supposed to look up at the trees with. And there I took a little mirror selfie because, you know, those used to be in style when I was younger. So say cheese. And then you count the dots, and that will tell you, oh, I counted this many dots. Plug it in an equation, and it'll tell you your canopy. Then we wanted to know how dense the trees were, so we used a keyhole prism. So I'd start with this 5 here, and if it extended beyond the 5, that was a good tree to count. And then what I did is I had to start here, and I had to count all the way around, and we hoped to get 10 to 15 trees. If we got more than 10 to 15, then I had to go up and use this 10 notch and so forth. And again, you plug into an equation, and they tell you the rest there. So this is pretty interesting. This is a Malaise insect trap. It looks like a tent. So the idea is the insect flies into the tent and is like, what's going on? Like, what's in my way? And insects like light, so they'll crawl up towards the light. And then we actually have a jar. So I have a picture coming up. A jar that sits here, and it will collect the insects. So then we'll take the insects back to the lab in La Crosse and weigh them. How much weight was at this location? Was this a good location for food or more of a poor location for food?
I feel like this sidewall is just...
There's my advisor teaching someone how to set up a Malaise trap.
This is nice and flat.
And here's me. Yeah, I later found out I was allergic to this grass, so not quite as fun as it should have been. But here, as you can see, this was a very full insect trap. They are not usually this full, but that was a good site to raise young. And then here's a better picture of what was in there. So we separate out the big moths, because that's what we're looking for. Big moths, big butterflies, and then we weigh that. All right. Oh, here was some of my findings. So this was a butterfly that was in one of our traps. So we'll actually let them go. If they're still alive, we'll let them leave. It's their free will. If they had just gotten into the trap, okay, we'll let them take off. And then this was a sphinx moth, which was that big moth I had earlier in my presentation, but it's a caterpillar starting a cocoon. I was so thrilled to find this. It was pretty cool. Oh yeah, some more butterflies. And
What you doing there, buddy? Taking in the sun?
Oh, fuck yeah. Oh, hell yeah. I feel so blessed.
And then this is that sphinx moth I was talking about. Quite annoying when you have your headlamp going and the moths are this size flying into your face. Quite interesting. Oh yeah. All right, and that was one of the moths. It was a little bit like, oh, I might leave, but it wasn't all there. Still waking up from having all that fresh air still. So yeah, saw some slugs out there. I thought that was pretty cool.
So I see this tail, and I'm like, what the frick is that? And it's a snake, but the snake isn't in a tree.
Yeah, so we were doing caterpillar surveys, and I was not expecting to find a snake, but
and here
we
I'm
did.
searching for cats. Come on. Ah! Oh, he's gone.
Yeah, so that's a rubber boa. I know that. I know that because I kind of touched it. They eat insects, they don't bite. So I was holding it like with the help of my friend, and then it started to move. And then it really started to move, and I was not so sure about that. But I redeemed myself later on at night when they are less mobile because it's cold. So there you have it. Those are all the methods. That's all I did in the field. So now I've collected my data. What does it all mean? Let's find out. So I summarized each foraging site across each different area. So I have 4 areas that I studied. Which ones were significantly different from one another in terms of statistics. So my Manaway site and my Snow Basin site, in terms of average shrub and tree richness. So how many shrubs did you see at a given site? 4.5 generally at Snow Basin and 6.6 generally at Manaway. So statistics told me Manaway and Snow Basin have different numbers of species than each other, right? So at Manaway, we have more different species than at Snow Basin. So why could this be important? Well, insects like woody plants, right? So having more woody plants and more species of woody plants is good. Many of these moths rely on these plants for their young, laying their eggs there. A specific paper that just came out in 2020 said that 14% of woody plant genera support 90% of lepidopterans. So to have more of these plants is a good thing for these lepidopteran species, moths, butterflies, the food source. And we saw 5 different species. Our quaking aspen is the populus. We got oaks, we got maples, and then we've got choke cherries, and I don't know if that was willows, I can't remember. But yeah, every habitat plot I surveyed had at least one of these important woody plants for moths. So I don't know if that's a coincidence, but I also thought this was interesting because one of my committee members studied these owls at these 2 sites and found that the site that I had more woody plants at overall was a more productive site, hatched more young, fledged more young, was more successful. So I don't know, moving forward it might be interesting to see, do these woody plants mean more moths, and do these more moths mean more babies, more young, more owls? I don't know. The other thing that was interesting is the land use historically. So we had our Snow Basin has a history of grazing. So that was the one with like less plants. So because of this, is it more monoculture? Like, did all the grazing of cows and sheep eat all the native plants, and therefore only the ones that were able to respond quickly took over? I don't know, but this Manaway site has little to no grazing.
We're surrounded, most definitely surrounded.
So I will tell you, there's still grazing going on because I found the cows.
They're just vibing.
Baby! So kind of some cool Utah environment here too. You get to see what I hike through every day. Oh, and more cows. Hi, cows.
We're all little people.
Hello.
Look at them.
Hello, cows. You came to the party.
I was meant to be a cowboy.
You brought him in.
Wow. This is a public grove, so it wasn't significantly different in terms of woody plants, but this is current grazing, and the Snow Basin was past grazing. So that could mean that in the future, this site could have less species moving forward. That might be something worth noting, that, hey, maybe we should rotate these cows a little bit more. But another objective was to look at the influence habitat characteristics had on the food, which was our large nocturnal moths. So I found correlation with our herbaceous plants, so those are like our smaller plants, right, that are out there, not woody. I also found that there's a better trend here after I defended my thesis. So there is a correlation between herbaceous plants and moths. Like I said, they like to lay their eggs on plants. There was also on the diversity of herbaceous plants was correlated. This also had another trend here. And then why would this be important? Same thing, these moths, they need to be supported by plants. Moths use them for pollinating as well. I thought this was interesting that 18 to 63% of moth larvae are eaten by birds. So that's a good source of food for those flams as well, the larvae, which, comes to the conclusion. Sites with good herbaceous plant richness and diversity, good foraging site, good food. And we saw, look at, there's one of those larvae coming into our box. That's one of the parents feeding the young, which is a different project that is still going on, checking out who's coming to the box. Same, canopy cover. So when there was a lot of cover, there were not a lot of insects. Well, this makes sense. Insects like the plants like a lot of sun. This relationship makes sense. But yeah, I just kind of summarize that, but yes, open canopy means different nutritional value. I thought this was interesting. Higher quality food and increased temperature actually helps larvae develop faster. So by moths putting their larvae in the sun, they grow faster, they eat better, and like I said about the owls, you get bigger faster, you're going to be more successful moving on. So yeah. And then test which habitat influences the mean distance traveled. So I took each point and I calculated the mean distance that they were from the nest. And so which habitat characteristics were correlated? Well, I did a regression analysis just to point this out. Tree density matters. Okay, so the distance your owl travels from the nest, as it increases, the mean distance traveled tends to decrease. So more dense areas mean travel farther, which makes sense. You're living in an area with lots of dense trees. Then we saw an almost significant herbaceous richness. So as the herbaceous richness increases, the mean distance traveled decreases. This result was kind of a surprise, but again, the herbaceous richness is important for the moths, all right? And then here we have the moths. Not quite significant. What you want is 0.05 to mean that you're 95% confident in your result. Well, ecology is messy, biology is messy. This is actually a pretty good, pretty close data point. And if you were going to take it as a significant result, as your moth biomass increases, your mean distance traveled increase. So that also surprised us a little bit, but the owls are not always foraging in our location points, right? They could have been defending territories, they could have been resting, they could have been doing other owl things. We don't know, but they were traveling pretty far when they were in good territories. So, and then this is why we have the GPS units, but test which habitat characteristics influence the foraging territories. So here we got our GPS units on again. And then what I did is I put it in ArcGIS Pro, which is a geographic information system software, and I just made polygons. So we called this their foraging territory. And then I had two other circles that I implemented. I have a picture later, but two other boundaries that I put in there. But all these little dots are where the owl went to find food while my tracker was on there. So canopy cover and tree and shrub richness were significant in terms of how far the owls traveled in terms of area. Okay, so as the canopy cover or more cover increased, the area that they traveled tended to decrease. So, and same, woody species, as the number of woody species increased, they didn't travel quite as far, which, like I said earlier, the optimal foraging, if you're not traveling far, you're conserving that energy, and you must be finding food pretty close by. So that's an interesting find. But here's that other map. So these other two circles were like the moderate used area, like, oh, I'm using this area quite a bit, and then the high density or the core area. And I had to make maps for my thesis to display this visually for people. So moderate area, high area, and notice the high area is close to the nest. Well, they're delivering that food, right? So some of these are likely not foraging sites. They're probably just delivering food. All right. And then same, so I made a bunch of maps. The different colors just mean the different bouts. I had the first week and then I had the second week of data. And then I thought this was cool. At Public Grove, where we had all our cows, we actually had 3 active nests that were pretty, they weren't pretty close, but these 2 are definitely pretty close. And so the question is, were they overlapping in territories, and how did that happen? So were they foraging? Maybe the green owl was foraging here in the morning, like at dawn, and maybe the orange was foraging there at dusk, or different parts of the week 1, week 2, but their territories actually overlapped a little bit, which is strange, right? You see these 2 have a hard boundary, so kind of an interesting find. So what does this all mean? So canopy cover, herbaceous richness, and the herbaceous diversity of plants are all important because they influence the food source of these owls. So moving forward, it'd be important to recommend to somebody managing this area, hey, let's focus on canopy cover, herbaceous richness, and let's make sure the diversity stays diverse, right? We also found that the tree density, herbaceous richness, and moth biomass could influence how much these owls are traveling. So if for some reason in the future that we need to support these creatures, we need to find areas where they don't have to travel quite as far, and these are the areas, right? And then lastly, we saw that the canopy cover and woody species could influence how wide their foraging territories are. So again, if we want them traveling less far, maybe making sure that we support these habitat variables. All right, so ultimately, all of this may inform us on the higher quality nest sites and resulting in the less energy expended traveling. So my conclusions from all of this is we do need to collect a little bit more data, and there was a second field season. I collected my data in 2021. My grad student friend Jason did a second year in 2022. So we're going to take that second set of nests and combine all the data and see if some of these trends come out a little stronger. But we are seeing some preference for habitat, and then we can ultimately take all this data and inform land managers in Utah saying, hey, if the climate here changes in these mountain regions, this is how we can best adjust the habitat, whether it's spreading seeds for more diversity of natural plants or something else, right? It's important to just have this information in case we need it. But I'd like to just acknowledge my 2 advisors were very helpful in all of this. Dr. Marcus Mika was in the field with me doing data, and Dr. Meredith Thompson, she helped me a lot on the side with writing my paper. And then speaking of my advisor, Dr. Marcus, he's working with my colleague Jason right now to work on a project where they're putting cameras in nest boxes to see what they are delivering to the nest. And I thought I'd share some of those with you. So here we got a moth delivered. And then parent number 2 came in and delivered a second moth there. So he's got a rather large prey on there, a mouse. Kind of weird, right? I said they don't eat mice. Every once in a while. Yeah, if you didn't see it, you could see it right in the opening there, that it was right there. It's a little mouse. Yeah. So if you enjoy watching owl videos, there is an opportunity for community scientists to watch videos for my friend Jason, if you're interested. He's looking for people. He's got about 52,000 videos that he's trying to get through. I don't think he's going to get through all those in the next year, but we'll see. He's taking takers for that. But otherwise, I had lots of help both financially and in the field from volunteers. So just want to thank my field technicians, lab assistants, anyone that helped me with statistical support, and then financial support. Okay, so I'll now open the floor to any questions that you may have. Yes?
Where does their name come from?
Their name, the flammulated? The stripe down their back is flammulated, is what they call it, the fiery stripe. Oops. Yeah. Yes?
How high up do you mount
I believe it's 15 feet is about what we mount them, because then we can still reach them with a ladder, but it's high enough so you don't have to worry about, say, like raccoons getting in with the eggs or red squirrels. So, yes?
How concerned were you about really dangerous animals being out there?
I was a little concerned about cougars, and we got to one box and my advisor was like, oh yeah, this is the box where I had a cougar circle me one time, and I just kept going. But yeah, I was a little concerned because I had a baby deer killed there, and I was like, oh, I'm out here and there's cougars? Oh no. Yeah, yes.
Do you leave the bands on, and do you leave the boxes out all
Yep, the boxes stay out all winter. Occasionally we have trees fall down, so we put up new boxes when that happens. And then the bands will stay on the owl for life. If someone elsewhere captures, say in Colorado where they're doing work, we'll be like, whoa, this owl started in Utah, maybe went south, and then the next season was in Colorado. We know that. That's good information, right? So lots of birds around here are banded, and we kind of track their movements that way and understand who's who. Yes?
So do they just like live insects?
Um,
Or they eat dead?
Mostly live. We have seen boxes that have dead moths in them, so I don't know if they're stashing those for later.
Because I was wondering about all those bugs caught in the can or the
Oh, yeah, we keep those at UW-La Crosse, and then we have that data in case we want to look at other projects. So actually someone who studies entomology or the study of bugs in Utah State contacted my advisor and was asking about looking at all the honeybees that we've collected. We get bumblebees sometimes and wasps in our nests, and then, or in our traps. So then we can then use that for data. It's not just wasted, right? Like anything we can share with other scientists is beneficial. Yes?
It's not directly connected with your study, but do you have any sense how much the expanding fire season, which apparently coincides with the range of the owl, is affecting?
Right. So thankfully in Utah at our study areas, we haven't had a fire, knock on wood, in a long time. So we have not seen personally how that will affect our owls. I'm sure if you talk to an owl biologist in Idaho or California, Oregon, some of those other states, they've had quite a few fires. I'm sure that they've been affected quite poorly, but I wonder if those owls after migration will just go to a different area until the growth has regrown. Yes?
What's the life expectancy of these owls?
Good question. So the oldest owl that we've found was one that my advisor banded in, I believe it was like 2009 he banded it, and she came back 9 years later. So, and then the summer after I was there, I think he found an 11-year-old female. So as far as we know on record, 11 years old is the oldest, which would seem about right. But on average, I think like 7 to 11 years is pretty old for an owl. Yes?
do they always go back to the same area where they were before?
Right. We get new owls all the time, but we do see a lot of old owls that we've had the previous years. My advisor actually has like a little family tree he's been keeping track of. So he put a geolocator on a female and called her Power Mama because she took that geolocator, went all the way to Mexico, and then came back the following year. And so we got to track her migration route to see, okay, where did she go? Well, she went down the coast of California and then came up the center of the United States. And he's like, why are you taking the scenic route there and coming back up the middle? Well, then she had some young who were banded, and one of her offspring settled down in a different site, but in Utah, different site. And then he was a mate with a woman, like a female owl. And she was around the summer I was out there in the same site that Power Mama used to live. Same site, but one box down. So it was kind of weird. This family was all coming to Utah, the same, I don't know. But we do not get a lot of Colorado owls that are banded. So we get either our own back or we get new ones, generally speaking. So, yes.
What elevation range were you looking at in
My elevation, so I only know meters. I guess I haven't looked it up. But I think the lowest point was 1,800 meters, and then to 2,100. So that's classified as like mid mountain range. So not alpine is like very tall. We're kind of in the middle. And then on my study site map, there were two that were very close together. And then the others are pretty far. Oh, that one would show it too. Yeah, so Public Grove had the cows, and 3 Mile was just a canyon. You could walk from one to the other if you wanted to climb that mountain, which we didn't. We called it, I think, taking the saddle, which we've only done in extreme cases, but there's a whole mountain on the other, or in between. Otherwise, 3 Mile, or Manaway over here, is pretty close. You could access it via UTV, but not by car, so we actually had to drive all the way around to get in there. And then Snow Basin is pretty far, so we stayed in Eden. It was about a 30-minute drive to Snow Basin because we had to go around the reservoir. And then Eden was pretty close to Public Grove. 10 minutes or so probably to get up there, so not too far. And then Manaway was the farthest, a 30-minute all the way around drive, but yeah.
1,800 meters is about 6,000 feet.
Okay, 6,000 feet. Wow. Yes?
Oh, why were these particular study sites selected? What were the criteria?
Right, so I actually adopted this study from my advisor, and he actually inherited it from another scientist, Carl Marty, I believe was his name. And he originally had Snow Basin and Manaway as his study sites. So in the 90s, he put up boxes and did research there. Then my committee member, Dave Oliar, he did his master's there. My advisor, Marcus, did his master's with these boxes. And then I'm not sure when these boxes got put up. Excuse me, I think when my advisor started, when he published in 2001 his master's, so I just kind of inherited their project. This is what he's always done the last 15 to 17 years he's been out here. So I'll have to ask him why the criteria are the way they are, but I'm thinking that he went to a location, and if he thought owls were there, he put up boxes. And if they were there, he went there every year to check on them. And once he found areas with owls, more boxes were put up. Yeah. Yes?
Are they an endangered species?
Not right now. They're of concern. So they have 1 to 3 young. They migrate. Migration kills a lot of birds if you have any hit your window. Yeah. So that's why they're of concern. There's small clutch sizes and a lot of migration. So, yeah. All right.
Thank you, Kristen. That was fantastic.
Oh.
Well received, lots of good questions, and excellent presentation. We appreciate your time at this and your time at presenting to us tonight. Thank you so much.
If anybody missed the notebook to sign in, it's back there on the round table as you leave, if you don't mind. Some of you might have missed, that would be great.